Good day, viewers, and welcome to my YouTube channel, Maths with Adevic. I am Victor Adewale Adeleke. Here, our major focus is to teach you mathematics from the onset, even up to tertiary institution. If you are yet to subscribe to my YouTube channel, do well to subscribe, like, and share. It is very important so that whenever I post full materials like this, you will always and certainly get notified. Okay, yeah, I want to quickly show the derivative of the function, the trigonometrical function sin x. So to find the derivative of this trigonometrical function, we are going to use the definition of a derivative, the formula which I already proved out in my very first class. This is a playlist in case you are just running into this video for the very first time. I've created a playlist on this, so you can click on the section, the comment section down the bottom. You will see all the videos that I've, or if you cannot wait, if you are, for your convenience sake, you can wait to the end of the video, or just skip to the end of the video and you'll find a link that takes you directly to my channel. So you'll find all the videos under the calculus topic, and I've been following them consecutively by steps from simple to difficult. So this is just the system of operation so that you can understand and grasp everything that is being done in the calculus. Okay, now let's see what we are doing. We are still under differentiation, not yet in integration, because I told you from the very first class that it is subdivided into two. Calculus is subdivided into two. We have the integration and the differentiation. So this is under the differentiation. So particularly to be precise, the trigonometrical function particularly. Okay, now let's see what if we are giving the function of x to be sine of x, what will be the derivative of the sine of x? So let's find that. So we are going to be using the definition of a derivative, also called the first principle. So we have as h tends to 0, the formula is just function of x plus h minus the function of x all divided by h. Now what do we do here? Let's see what we can do. So we just say dy dx will be equals to the limit as h tends to 0. Now the function of x plus h is what? It's the sine of x plus h minus, what is the function of x? The function of x is what? The sine of x all divided by h. Then from here we still go the same way. They take the limits as h tends to 0. What is the sine plus x plus the sine of x plus h? Now following this identity which I already showed here, these are the notable identities. These are standard limits, and this is an identity that we are going to be using to profile solution to this question. So we have the sine of a plus b is equal to sine a cos b plus the cosine of a, the cosine of b. So that's the same thing that will be applied here. So we are going to have the sine of x plus a plus h, will become the sine of x and the cosine of h. And I've already explained in my other class that this is not just an hyperbolic sine. This is not an hyperbolic h. That is why I'm bracketing it. It is not an hyperbolic h. It is the increment in x. So once you note that, so let's move on. So we have plus the cosine of x and the sine of h, which is the increment, all divided by h. There's a very huge error here. There's a very huge error. What we just did now, we only successfully wrote sine of x plus h. So we are supposed to write the sine of what? Of x also. So we are supposed to subtract the sine of x from it. So let's see how we can minimize space to write that. Let's see how we can minimize space to write that. So we have the sine of x, the cosine of h, plus the cosine of x, the sine of h, minus the sine of what? Of x, which is that. Yes, so it's okay now. So from here, what do? We can factorize. You can see, okay, we don't want to waste space because we are trying to minimize space here. Now we can factorize. This is sine of x, this is sine of x. So we can bring them close together. There's a minus sign here, so we should be mindful of that. So if we are doing that, so we have that dy dx will be equals to the limit as h tends to 0. So we are factorizing what? Sine x out. So the sine of x comes out, and we are left with the cos of the increment in x minus 1. Let me write this well so we are not confused. Then minus, sorry, plus, yes, plus the cosine of x, the sine of h, all divided by h. Now, I also explained in my other video that we can, instead of doing this, we can break this into two. We can break this into two, and we have all divided by h here, and we also have, this is the sine, this is the cosine, sorry. So we also have all divided by h. So this can be rewritten to become dy dx equals to the limit affects each of these algebras inside the brackets. So the limit is going to affect this is the numerator and the denominator, these fractions inside the bracket. So what do we do? So the limit affects just this. When the limit affects this, we can write it as, okay, let me get, we can write it to be the sine of x to the limit as h tends to 0, the cosine of h minus 1, all divided by h. Then what else? We can also say plus the limit as h tends to 0. Then we can say the cos. Okay, let me write it the way I wrote this, because this 2 is multiplying this. So we have what? The cosine of x first, then the limit as h tends to 0, the sine of h, all divided by h. Yes. Now, if you see this and this are the two standard limits that I've given, that I've shown from the very beginning of the class. So all this represents what? 0, and everything here represents 1. So what do we do? So your dy dx, which is your derivative of the sine of x, is finally going to become, this is sine of x all multiplied by 0 minus the cosine of x all multiplied by 1 plus. So everything here eliminates. So what do we have finally? Our final result is the cosine of x. So whenever we are given a trigonometrical function, the sine of x, to find the derivative of, the answer certainly is going to come out to be the cosine of x. If you are yet to subscribe to my YouTube channel, do it to subscribe, like and share. It is very important so that whenever I post helpful materials like this, you will always get notified. Stay tuned.